He said,
Okay, good. All right. Now, okay. So exponentials look like this. Okay, so there's my H, A, and K. It says for the locator point, HK is on the asymptote, so we use H comma K plus A. Okay, so moving into like what is H in this problem? 1. Okay. And what is K? -2 plus 5 is 3. And then horizontal asymptote at y equals, wait, we did this wrong. No, we didn't. It's just, okay.
I like your shirt, Tom.
No, thanks. I was super excited to wear it. What's wrong? What?
I like
Oh, thanks.
Brazil.
It's not. Yeah.
Where can I get that shirt?
On the Amazons. Um, so Miss Rice and I, we have the same shirt on today, but we won the best duo in the yearbook. So we're thinking we should wear these shirts for that. Don't you think this needs to be in the like timely, as timely as this is? Did you take you're not on Amazon right now? Okay. All right. Now, mental math. Your fave. What is, okay, I'm going to block all these things with my fingies so that you don't have to think of too many things at once. Okay, so we're plugging in the 2. 2 minus 1 is what? 2 to the 1 is 2. 2 times 5 is 10 minus 2 is 8. Okay. 3 minus 1 is 2. 2 to the 2 is 4 times 5 is minus 2 is, okay, well now we can see why that graph went up to 18. Okay, now this is spicy. 0 minus 1, that's not the spicy part. Negative what? What is 2 to the -1? 1/2. What's 1/2 times 5? And you could do it in a decimal. 2.5. 2.5 minus 2, 0.5. Mrs. Talbot, are you going to ask me to do this in my head in the test or quiz? No, I am not. Okay. -1 minus 1. -2. 2 to the -2. 1/4. 1/4. Okay. 5 times 1/4 in a decimal. 1.25. 1.25 minus 2. Nice. Look at you guys. I know. Okay. So -1, -0.75, 0.5, 3, 2, 8, 3, 18. Oh, wow. Wow. Don't look. Don't look. Don't look. Don't look. Don't look. I think she'd never got before. Are you supposed to go through the points? I'm not sure. Okay, vertically stretch by a factor of 5. Shift right 1. Shift down 2. Good practice, good practice. We don't do the exponentials often. Okay, now scoot your paper down to the absolute value inequality, number 12. Mission people still going. There's no reason to go fast today. Today's notes are not long. Yes, okay. So, right, step 1, pretend you have equals. Okay, and on this problem, I'm trying to trick you. Can you see Mrs. Talbot's trying to trick you here? Anybody see what I'm trying to make you do? True, I'm trying to make you make this 14, and you cannot do that. Yeah. Okay, so when you've got a bunch of stuff with an absolute value, you have to get the absolute value alone first. So -4. And it's true what you were saying. I'm also trying to get you to distribute the 10 inappropriately, but I don't want you to do that. Yes. Okay, now you're at the point where you want to undo the absolute value. And so plus or minus. Yeah, out of that whole mess, I got 1 and 5. Satisfying.
Mhm.
Like, okay, I'm gonna give people a minute to catch up. Okay. Next question, open or closed? Closed. All right, now I think there's a clear choice on what to plug in to test. Because I'm lazy. Now you can do 0. I'm not suggesting 0 this time. You can do 0, it's fine. Can you predict with a crystal ball what I would suggest? 3, nice.
3.
Mm-hmm. Thinking it's gonna be false just because maybe not. No, it is. Okay, anyway. So 4 plus 10. So 9 minus 9 is 0. Okay. This becomes 4 plus 10 times 0, which is 4, which is false. Yep. Okay, don't forget the final answer. Yep. Arrows out, just like the arrows out in your picture. Okay, now before we move away from the packet, can we just look at the stamp sheet side real quick? I'm gonna do as much as I have time for, but I want to know where I left off, so I think I need to stamp 39 to 43. Digital escape 52 to 55, 56 to 61, your FIAB, and then today's notes. Does that look correct?
Yeah.
The only thing that's in your packet is the digital escape. So when I do come stamp, if you could have it open to that work page, that would be great, but not right now. We're gonna do 63 to 66 first, which is all in the notebook. And then hopefully while you guys are working on the homework, which is the mid-chapter worksheet, the 10 problem, I'm going to stamp is my goal. Just so you know, I'm gonna use 2 colors, one for regular, one for inverse, just like I did through all of our inverse stuff. Okay, so before I write anything further, I just want you guys to recognize these two in A and B as me switching the X and Y on an exponential. Okay, so look at A. That one was originally Y equals 2 to the X, but then I flipped the X and Y. Can you tell? Okay, so let me say that again. It was originally Y equals 2 to the X. That was the regular exponential. And then with the inverse, I flipped the X and Y. Okay, but we learned on Wednesday that we can't really write it like that to put it in a calculator or anything. And so the inverse is a logarithm. So we don't write it like this, we write it like this. Of this, like this. Okay, so I want you guys to understand the pieces of a logarithm. This is really important to me that you use this word vocabulary, I'm trying to say. This is the base of the exponent is 2. And this little baby number is called the base of the log. And the base of the exponent is always equal to the base of the log. So those numbers should always be equal. Okay, so tell me what b is then. Mm-hmm. Log base 5 of x. Beautiful. There's the full word logarithm. And you can't fit that full word on your calculator, so they put it down to 3 letters of log. So we're going to say log most of the time because it's more fun. Okay, so we're going to talk about inverses and finding the steps and the backward steps like we've done with all the rest of our inverse problems. Okay, so let's pretend that I gave you a problem and I said, all right, this is an exponential. Y equals 7 to the x. No big deal. Just your garden variety exponential. Okay. When I ask you to list the steps of what happened to x, what you're going to say is that it was 7 to the power. It's a blink. I call this 7 to the. It's like just like a, like a little, like you put something in the blank, basically. Yeah. Okay, now if I were to graph the picture of 7 to the x, I'm just going to draw this really rough. There would be a horizontal asymptote. And my exponential would go along the asymptote and then curve up like that. Yeah. Okay, now let's compare that to its inverse. So the inverse of this would be log base 7 of x. And when you wrote your steps, you would call that step log base 7. So these are the two things that undo each other. I want to remind you what I'm saying is like, you know how like we have x minus 1 squared, and you would say, okay, step 1 would be minus 1, step 2 would be squared. Are you with me? Okay, and then the inverse steps. So step 1 would be plus or minus square root, and step 2 would be plus 1. Okay, what I'm saying is when there's an x in the exponent, your step is going to be 7 to the, or 3 to the, or 5 to the, or whatever. And then the step over on the inverse side will be log base, whatever the base is. Okay, we're going to have lots of time to practice it in number 65. Don't worry. Okay, now a log graph has a vertical asymptote instead of a horizontal one, which makes sense, I think, if you think about flipping the x and y. And the graph of it looks like this. Okay, now this is very important. You need to make a note. I am going to teach you how to do this on the graphing calculator, not right now, but the graphing calculator is dumb. Literally, it's stupid. It doesn't, it like cuts it off. So right here, it goes doodly, 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 and it stops right there. It makes it look like a square root function. You have to know better than that and make your arrow go all the way down. The reason is because if you think about the table, it's plugging in whole numbers for X, right? It's not smart enough to go, oh, I need to plug in all these baby fractions to see that that goes down. It's just not gonna do it. Desmos will, the graphing calculator won't. It just, all you need to know is you just have to make an arrow yourself. I'm just warning you ahead of time. If you graph these on the graphing calculator, they're gonna look bad. But we can overcome with intelligence. Okay, now we're gonna practice the steps. Oh no, that can't be good. Okay, here we go. When I plug a number in here for X, there's only one thing that happened to it. Log base 9. Okay, that's it. There's only one thing. Okay, how do I undo log base 9? 9 to the power. These two things undo each other. So that means the inverse is 9 to the X. Okay, B. When I plug a number in for X, there's only one thing that happened to it, 10 to the power. How do I undo 10 to the power? Log base 10. You're getting it. It's happening. Okay, so that means the inverse, log base 10 of X. Okay, now in C and D, I put 2 steps. Ooh, okay, here we go. All right, so I plug a number in for X. What do I do first? Parentheses first. Add 1, beautiful. Okay, after I add 1, then I would log base 6. Okay, now just like your inverse problems, undo the last thing that happened first. So how do I undo log base 6? 6 to the power. How do I undo plus 1? Minus 1. Okay, so we have y inverse step one is 6 to the power of x. And then minus 1 on everything. Is it happening? Are we doing it? Okay, last one of these. Plug in a number for x. What do I do to it first? Yep, multiply it by 2. And then 5 to the power. Okay, how do I undo 5 to the power? Log base 5. Divide by 2. Okay, step one is log base 5 of x. Divide by 2 on everything. So I need you to add this into your repertoire of undoing steps. So when you see an exponential, now you know what to do. Log. Okay, there's one more problem. And it's my favorite. Guinan circle time. You know what's really sad? When you take pre-calc, he doesn't teach it anymore, but when you take pre-calc, he doesn't call it the Guinan circle. The loop-de-loop or the snail shell or something, and I'm like, no. You are a genius. Take credit for your beautiful circle, Mr. Guinan. Anyway. Okay. All right. There's a lot of these, but they're very short. It goes to I, but they're very, very, very short. It takes almost longer to write the problems down than it does to do them.
First time in university.
No, we're evaluating. These are different. Do you remember that puzzle I had you guys do? That's like this. But what you need to know is it's the last problem. Mhm. Okay, now I'm going to do the Guinan circle, but to evaluate these, I need something to make my circle go around. If there's nothing over here, like these guys, put equals x, because that's what I'm going to solve for. Okay, now make your Guinan circle. Okay, so here's how the Guinan circle works. You start with the base of your arrow, becomes the base of your exponent. Then you follow your eyes around the circle, so this becomes the exponent. And then follow your eyes around equals 32. Okay, then it becomes the same base exponential problem. 32 is 2 to the what power? 5. 2 to the x equals 2 to the 5. Cancel, cancel. X equals 5. Okay, B, nothing there, but equals x. Guinan circle. Okay, base of the log is the base of the exponent. Follow your eyes around. Follow your eyes around. Okay. 1/2 is 2 to the what?
-1.
Nice. You're on fire. Did you sleep good? Good, it's good. Okay, what's my exponential? 2 to the x equals 4. Dang. Seriously. Okay, now the bottom ones there already have equations, so we just need to rewrite them to exponential. 2 to the x equals 0. This is actually no solution. What is 2 to the 0 power? 1. You can play on your calculator forever for the rest of your life, and you'll never figure out 2 to the what is 0. Okay, so this one literally just I know. Didn't have to think. Okay, now remember from last week, what is a half exponent? Mm-mm. 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 Nope.
Double.
Nope. Square root, thank you. Okay, now in GH&I, I'm going to teach you how to cheat if you're lazy. If you're not lazy, what we did was totally great. Will work every time. But if you're lazy, like your teacher, just don't want to write all that stuff, I'm going to teach you the Corvette now. That was the Camry. Okay. Now, if you understand how inverses work, you know that log base 3 and 3 to the power undo each other. So what I can do in this problem is instead of putting equals x, doing the circle, blah, 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 what I can do is say log base 3 of 3 to the 4th. Because 3 to the 4th power is 81. And log base 3 and 3 to the power undo each other. And the answer is 4. Okay. Log base 7 of 7 squared is 2. Yeah. And then look at I. Bam, bam. So, okay, so remember, log base and base to the exponent undo each other. So you can cancel them out. All right.